Volume! More volume! Oh, wait. This is supposed to be a math lesson. Sorry. Got confused for a moment. Okay, I'm back. I'm Mr. Lineberger, and today, instead of talking about rock and roll, we're gonna be talking about rockin' math. So let's look at a different type of volume. Volume, when we're in math mode, means the amount of space that something occupies, or the amount of space it contains. What's the volume of this container? In other words, how much does this container hold? That's right, 1 gallon. A gallon is a unit of volume, but we can be more specific than that. A gallon is defined as 231 cubic inches. What in the world is a cubic inch? Imagine an inch. Now imagine a cube that's an inch wide. If it's also 1 inch tall and 1 inch deep, then we have a cubic inch. Volume of a rectangular prism is determined by length multiplied by width multiplied by height. That's multi-step multiplication. Try saying that 3 times quickly. But seriously, try saying it. So, back to our gallon-sized carton of milk. If a gallon is 231 cubic inches, we could imagine it like this. Let's start with 100 cubes. Add another 100, that's 200 cubes. Let's drop 30 more cubes in 3 groups of 10. And a final cube to make 200 plus 30 plus 1, or 231. Throw all those in a gallon milk carton and it would be perfectly filled. Let's try another example. This one is probably even easier. I wonder, what is the volume of this cube? Well, let's first imagine that each of these smaller cubes is 1 centimeter wide, tall, and deep. That means the volume of one of the small cubes is 1 cubic centimeter. If that's the volume of 1 cube, we know that a side is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cubes. 9 multiplied by 1 is 9. So one side is 9 cubic centimeters. When we look at the cube this way, we can see that one side is really one of 3 layers of the cube. If one layer is 9 cubic centimeters, and there are 3 layers, then the overall volume is 9 multiplied by 3. The volume is 27 cubic centimeters. Let me demonstrate that for you in another way. Imagine these base 10 blocks are a cubic centimeter in volume. I'll take 4 and make a row. There. Then I'll add more blocks until I have 4 rows. Like so. How many total blocks are there? 4, 8, 12, 16 total blocks. So we know the volume of this is 16 cubic centimeters. Now, if we were to add another layer on top, we would have 2 layers, each with a volume of 16 cubic centimeters. If this is our final rectangular prism, 16 plus 16, the total volume would be 32 cubic centimeters. If I were to add 2 more layers to make the final figure an actual cube, what would the volume be? Correct. 64 cubic centimeters. Okay, we're back. Now, let's look at some real-world examples to help you get a good feel for volume. What about a coffee cup? It's got a volume of about 240 cubic centimeters. A football? That's about 4,800 cubic centimeters in volume. It's a lot more volume than a coffee cup. A basketball is a little over 7,000 cubic centimeters. And your average oven? The volume of a normal oven is a whopping 141,000 cubic centimeters. But if we switch units and think about cubic meters, that's much less than half of 1 cubic meter in volume. Now, let's get down to the real problem. Have you or your family ever packed a car for a trip? Usually everyone gets all their bags together and you just hope that they all fit. Then you load them in the trunk, and any that didn't fit, well, in my family, that means someone gets to carry a suitcase on their lap. But what if we knew the volume of each bag and the total volume of the trunk, the amount it can contain? If we knew that, we'd be able to make a reasonable estimate to determine if our bags will fit in the trunk or if someone is going to have to share their seat with luggage. The power of math. When I go for my audition for Math Metal, I want to bring all my guitars, but I'm not sure that they will all fit in the trunk of my car. I want to use some math to help me know how much space my guitars will take. All my guitar cases are the same shape. I like these cool rectangular cases because they're easy to stack. My cases are 5 inches high by 40 inches long and 15 inches wide. I have 6 guitars to take with me. Let's figure out how much space those guitars are going to take. You see, solving a volume problem is a lot like figuring out the area. Really, we can start with area. Let's use some multiplication to determine the area of one side of the case. It's 40 inches long by 15 inches wide. How could we represent that? One way would be to think of 40 as 4 groups of 10. I can do 10 times 15 in my head. 15 tens is 150. If I have 4 groups like that, I just have to add 150 4 times. So, 150 plus 150, that's 300, plus 150, that's 450, plus 150, that's 600. The area of one side of the case is 600 square inches. Now, I can think of volume. If I made my entire case out of cubic inches, I'd have 600 cubes to make up one layer. I also know that my case is 5 inches tall, so I have 5 layers. I just need to multiply 600 by 5. 5 groups of 600 would be the same as 600 plus 600 plus 600 plus 600 plus 600. I'll give you a minute to figure that one out. There. Are you done? Yes, 3,000. My case is 3,000 cubic inches in volume. I've got 6 cases. 3,000 cubic inches 6 times. That's a big number. So let me make 6 times 3,000 an easier problem. I can think of 3,000 as 3 times 1,000. So 6 times 3,000 is the same as 6 times 3 times 1,000. 6 times 3 is 18. 18 times 1,000 is 18,000. When you stack all my guitar cases together, they take up 18,000 cubic inches. I happen to know that my trunk holds 20,000 cubic inches of volume. My guitar cases take up 18,000 cubic inches. That leaves me with 2,000 cubic inches to spare. I might be able to pack my smoke machine as well. Thanks for helping me figure things out. Today we looked at some strategies for multi-step multiplication. We used these strategies to determine the volume of a puzzle cube, a carton of milk, and 6 guitar cases. Until next time, keep rocking out, math style.